Hi. It's exam 2 review. So enthusiastic, I know. I gotta write that. Anyway, it's on chapter 3. Plus asymptotes from chapter 2, which are all types of asymptotes. And we already had the limit definition of the derivative on the previous exam. So I said that we're going to skip it on this one since you voted to have it on the previous exam. You remember the limit of h goes to 0, right? F of x plus h. So I guess that's out. I was still thinking about continuity to put that in, but then there is exam 3, there is final. Continuity will be very important for your next course, obviously, and if you don't know it, well, it's an issue. So I guess we'll just keep chapter 3 and asymptotes. We'll keep the limit definition of the derivative out because it was there on a previous exam. It might show up again on the final, but you need to know how to deal with derivatives. So as we are looking at the review, the most important thing is basic derivative. Right? Basic derivatives. So that is the fact that the derivative of constant is 0, derivative of sine is cosine, derivative of e to the x is e to the x. So all of those basic derivatives, basic shortcut formulas that you have to memorize are on this list. Now they are spread throughout few different sections because there is a section on exponential and logarithmic derivatives, there is a section on trig derivatives, there is a section on polynomial and other basic stuff. So I believe 3 or 4 sections are actually under this. So I will just put in parentheses all, meaning all of the sections that contain trig, that contain exponential, logarithmic, and everything else. Then we have the product rule and quotient rule. Then we have chain rule. Then we have implicit differentiation, logarithmic differentiation, and I think that's it for the rules. Obviously, here in blood, tangent line for all of these, because tangent line is you take the derivative, you plug the value, you get the slope. It doesn't matter which way you take the derivative. Whatever the problem is, you will take the derivative using one of these rules. You have to. So the tangent problem might show up with logarithmic differentiation or the chain rule, or maybe 2 tangent lines. Oh, actually, wait, we have linearization, which is a form of tangent line. So we have linearization. Wait, did we have linearization? Nah, that's in chapter 4. Oops.
All right.
Oops. Yeah, that's in chapter 4. Hey, why'd you get my... we have the related rates. And that takes care of the exam. So as I said, as you're looking for the tangent line, you might have to do product rule, you might have to do implicit differentiation. But also make sure you can take higher order derivatives, right? So second or third. Make sure you use proper notation. That's the most important part. So make sure you use proper notation. And I think that covers everything. Now I will ask if you have any questions. No. Unless you're requesting a special exam. I taught physics in the past, so I can write an exam for you if you're interested.
Like there wouldn't be a problem like there was on the law where like t equals 6 seconds and an average.
Well, that's, just plug in the derivative. That's you learn that instantaneous speed is the derivative. So if you have equation, you take the derivative, plug in. Average speed is the algebra slope, right? The whole trip divided by the time. Average is simple division, and instantaneous is derivative. That's what. Yeah.
When you're finding the tangent line, say you are only given like an x value, or sometimes it's put as a, you are always to find the y, so then eventually after you find that and then find m,
you can find b then, yeah.
Yeah, but you're always plugging it back into the original given equation, right? Never the derivative of the original equation to solve for y. So
yes, because y is f of x.
Yeah, okay.
Y is f of x.
Yeah.
Connect that, right? It's not y prime is f of x. It's y is f of x. So if you're looking for y, you should be plugging original equation.
Yeah.
At y prime, we are going to plug stuff into y prime in chapter 4 when we do something that is called first derivative test. But that's going to be later. So right now you are only worrying about plugging original equation to get y, because y equals f of x. As I said, you just take the derivatives. Don't panic about that. Yes?
For notation, if your original equation is just given as like y equals, for example, as opposed to like f of x or something like that.
That's the same thing.
But when you're like, can you write like y prime of x, or should it just write y prime equals, since there's no...
Well, it's, those are the gory details whether you're going to write f of x or y. You can write f of x prime every time.
F prime x?
Yeah.
Okay.
You don't have to use y ever. At all. You can just, because y is equal to f of x, so then you have f of x, f prime of x, f double prime of x, f triple prime of x. So you can never, you don't ever have to use y. Yes?
You're getting the tangent line, so like find the tangent line. So you can't be like put it as point slope format.
Sure.
So we don't have to...
Well, once you are done with the tangent line, you first have to find the derivative and then plug the value in to get the slope. Then you plug the value in the original equation to get the y. At that point, whether you're going to use y equal mx plus b or the point slope, it doesn't matter. You will get the equation into y equal mx plus b form at the end. Either way you start, it doesn't matter.
Can we do one of the examples?
Which one? Excellent. You know how I roll on the review day. You ask questions, I provide answers. And then on the exam, we swap the roles. I ask questions and you provide answers, hopefully.
Are we gonna start new stuff today?
Yeah, I mean, people didn't hand in the lab yet. There's lab 3.
How many labs are there? 5?
We just like if we're at that stage now, can we do some simplistic differentiation
Like this.
examples?
We are waiting for the tangent line problem still.
Oh, we're doing a tangent line first.
If I can find it.
Well, let's squeeze let's do your problem first. So we're not
I guess I'll just
page
200. I guess 23 looks like fun.
23 looks like fun. Wow. Beautiful. Find the derivative for square root of x to the 4th plus y squared is equal to 5x plus 2y cubed. To find the derivative, I will put the operator in front in respect to x this time. So I have square root of stuff. So the derivative of that is 1/2 stuff to the negative 1/2 times the derivative of the inside, which is 4x cubed plus 2y dy dx equals to, now the other side is just straight through, now we simplify this. This is going to be 4x cubed plus 2y dy dx divided by 2 square root of x to the 4th plus y squared is equal to 5 plus 6y squared dy dx. Now we need to put all of the dy dx terms together, but there's a square root in a way and so on, so that gets multiplied to the other side. We get 4x cubed plus 2y dy dx equals to 10 square root of x to the 4th plus y squared plus 12 y squared square root x to the 4 plus y squared dy dx. So what I did is I multiplied the square root on both sides. And now we can finally have all the dy dx terms on the left. So I have the 4x cubed is going to go to the right. So 2y dy dx stays put, minus 12y squared square root of x to the 4th plus y squared dy dx. So those terms go on the left. And then 10 times square root of x to the 4th plus y squared minus 4x cubed on the right. Now when you factor out dy dx on the left, you are left over, and you just divide both sides by wonderful example. Should you have the tangent line associated with this problem, hopefully you will not be solving it all the way to the bottom like this for the slope. You would immediately plug in everything you have, your x and y, and replace dy dx with them in this line here. And a lot of calculations would clear out, and you would not have to drag so much algebra and worry about any of that stuff. You would be able to quickly come up with the m equals whatever number. So for tangent line problems, you always have to compute the derivative. You don't have to simplify. Right? Found the tangent line problem? Oh, yes. I will make the trip as soon as I put the line. Oh, no, no.
So this equation is a
Beautiful. Oh. We have a wonderful example for the tangent line. And one. That's my exercise for today. Okay? I love doing my exercise early, so I don't have to worry about it during the week. 3 reps next. Perfect.
Makes me so style too.
What?
Makes me style
No, it's all good in June with every stuff. I don't want to raise the gear and there'll be guys like you that pick it up. I don't have to worry about it.
Just drop it there. Just drop it instead of the.
No, I don't even think so. Steady. Why would I?
That's not fun.
Oh, I will. I had to get the words. Is the bag made out of rice or no? The next problem is the tangent line problem. So tangent line at -2, -1/2 for y equals x cubed over x squared minus 6 to the 4th. Now, obviously, I'm going to take this derivative using logarithmic differentiation rather than going through all of the stuff, right? So y prime is equal to, copy the problem as is, and then just write out the derivative, which is 3 over x minus 4 times 2x over x squared minus 6. Now, if you haven't practiced the logarithmic differentiation, obviously something like this is not available to you, which means that you would have to grind through the quotient rule. So all I need to do now is to plug x equals -2 everywhere. So m is equal to -2 cubed over -2 squared minus 6 everything to the 4th. 3 divided by -2 minus 8 times -2 divided by -2 squared minus 6. And that's going to give me a slope. Let's see, -8 divided by -2 to the 4th is 16 times -3/2 minus plus 16 over, this is another -2. So this is -8 over 16 is -1/2, and then -3/2 minus 8. Oh no, that was already common denominator. I don't want to write -8. Minus 16 over 2. That gives me -1/2, and then in parentheses -19 over 2 for the total of 19 over 4. So m is 19 over 4. And our point is -2, -½ You can plug this now into either y equal mx plus b, or you can plug into the slope form, whatever you like. So -1/2 equals to -1/2 equals to 19 over 4. That's the slope. Times x, which is -2, plus b. So -1/2 is equal to -19 over 2 plus b. So that's 18 over 2, which is 9. So y equals 19 over 4 x plus 9. So that was a tangent line problem where I used logarithmic differentiation. There are other ways in which you can take this derivative. One would be quotient rule. You can also do this derivative using implicit differentiation if you multiply both sides by the denominator. So there are, let's say, 3 ways to take the derivative. They all must give you the same 19 over 4 slope at the end. So you could have, the problem was this. You could have written it like this. And then take the derivative implicit. You can do that as well. So in this case it would be implicit. You are still looking for the same answer. Or do the quotient rule with chain rule embedded. Right? The quotient rule would be y prime is equal to, right, copy the bottom and then square it, which means now it's to the 8th. And you can see how much worse this becomes, because now you have to deal with that. And then x squared minus 6 to the 4th, and then times 3x squared, and then minus x cubed, and then 4x squared minus 6 cubed times 2x, right, the chain rule. So that takes forever. If you learn logarithmic differentiation, that stuff is designed to make a joke out of these kind of derivatives. But then if you don't learn it, then you will have to struggle one way or another. Any other questions for the review? No more questions? Wow, you're really ready for the test. Maybe we should do it now. I'll make up the test. 2 seconds. All right, so that's it for the review. Shut it off. So basic derivatives, chain rule, product rule, quotient rule, implicit differentiation, logarithmic differentiation, tangent line for everything, and then don't forget the trig, the inverse trig, those 2 formulas you must know, the inverse tangent and inverse sine. The other 4, if they show up, I'll give you the formula in the text of the problem. But the 2 inverse ones you must know. Inverse tangent and inverse sine, because those will be all over the place in your Calc 2. And differential equations later on. What else? That's it. All right. And see you tomorrow.